Okay, these are going to be our notes on our next section with our circles. This is what we call with tangents. It's kind of a weird word, but a tangent line intersects a circle at exactly one point. It's called the point of tangency. So what that means is it touches at this point. If it's tangent, which means it's touching, remember at one point, it's touching at one point, it's perpendicular to the radius. So this creates a right angle if it's perpendicular right there. That's going to make this real easy for us to do because we're going to be using Pythagorean theorem a lot on this particular section. So what I'm going to do is I'm going to do one of each type, and then I'm going to, you will have the notes already on your assignment. They're already filled out, so you can look at the other part if you need it. So if we look at number 1 here, it tells us determine if this is tangent. So they're wanting to know, is this line perpendicular to the radius? So let's check it. If it is, we can do Pythagorean theorem. Remember, a squared plus b squared equals c squared. And c is always our hypotenuse. So we're going to say, is 8 squared plus 15 squared equal to 17 squared? Well, that gives us 64 plus 225 equals 289, which is true. So yes, it's tangent. If that had not been true, then we would say no. Okay, number 3 says that JK is tangent, so find x. So it tells us this is tangent, so it's forming a right angle. Remember, a right angle is right here at the corner. So we have A, B, C. So let's set it up. 7 squared plus 19 squared equals x squared. This gives us 410 equals x squared. Remember, we have to take the square root of both sides. So if I want to take the square root, you can put that in your calculator. And remember, if you don't have a calculator, a graphing calculator, or one that'll do the square roots, this one, this app that's right here where it says EduCalc calculator, that's going to be one that's an easy one to find. So if you look on the App Store, that's going to be an easy one to use. So x turns out to be 20.2. Some of these we have to use the fact of the radius. Remember, this is a radius. So we already know this is a right angle. But if I'm trying to find out just this part, I can do Pythagorean theorem first, and I can find out this part. But if I need to know what x is, we got to keep in mind this is also 10 because this is a radius. Okay, so if I'm using A, B, and this whole side is C, I have 10 squared plus 24 squared equals this whole side. Okay, we'll call it C squared. And so we end up with 676. Equals C squared. And so my C, if I take the square root, gives me 26. Remember, that's not your answer. That's the whole side. So if this whole thing is 26, 26 minus 10 gives us x, which is 16. And we can do that because this is a radius. Okay, so we need to be careful about that. That's how they found out over here on number 6. Beside that, if this is 11, this is 11, which means this whole side is 22. Therefore, you can do Pythagorean theorem. Okay, so let's look at the same thing down here with number 7. If this is 3.5, that means this is 3.5. Remember, our right angle is over here where it just touches. See, this one doesn't touch. It's inside. We're talking about the one that's on the outside. So this is A. If we add these two together, we get 7. So there's B. And then this would be our C if we're thinking about Pythagorean theorem. So 7 squared plus 6.4 squared equals our x squared. X is the whole side. So we get 89.96. I'll take the square root. We end up with 9.5. And you can round to 1 decimal place if it doesn't come out to be exact. Remember, you can pause the video and go back if it's too fast or you didn't have time to write it. That's a good thing about this is you can always go back to it. Okay, number 9. I do want to go through this one because it's got a couple of steps. If this is my radius, that means this is also my radius. This is the side that's touching, so there's my right angle. So let's think about it. We don't know what this whole side is. I do know that it's x plus 10. So if I write this out with Pythagorean theorem, and say, okay, this one, x squared, plus this one, right here, 20 squared, equals x plus 10 squared. So I have my, if you think about it this way, our A, our B, and our C. So think back to algebra. If we said x plus 10 times x plus 10, this is x squared plus 10x. I'm going to use a distributive property here. Plus 10x plus 100. So this is x squared plus 20x plus 100. So we kind of have to do our own little side note over here. Okay, so now we have x squared plus, this is 400, equals x squared plus 20x plus 100. If you start simplifying, that cancels out from both sides. We can subtract 100. So we get 300 equals 20x, or x equals 15. And so that's where I can find x. And that's your radius. Okay, so if it asks for maybe LK, the whole thing, you would say 15 plus 10, which would give you 25. Okay, these are 2 more notes here, that if this is from one point and it's tangent, in other words, creates the right angle there, this line is equal to this line, so AB equals that one. Also, it says if a polygon is circumscribed, which means it surrounds a circle, all sides are tangent. So in other words, it means that they're all tangent to the radius if I were to draw those to the center here. And that's something that's important that we can look at later, because what it tells us is this is the same as this one, this is the same as this one, and that's the same as that one. That's the reason it's important for us to know that. Okay, so for number 10, because this is one point that touches each side of the circle, it says assume that all the segments that appear to be tangent are tangent. So that means that these are tangent to the radius. These are equal. So 5x plus 23 equals 8x minus 19. If I subtract 5x from both sides, I get 3x. I'm going to add 19, get 42. And so x turns out to be 14. Number 11 is going to be the same as that one. You're just going to plug your answer back in. So I'm going to leave that one for you to look at on your own. I do want to look at 12, because on 12, it wants us to find SV. So the one that we're looking for is this one right here. Okay. These appear to be tangent, so if that's true, that means we can set these equal. 10x minus 41 equals 4x plus 7. If I solve, I end up with 6x equals 48, or x equals 8. Okay, remember that, that's not what we're looking for. If I plug that 8 into right here, I end up with 80 minus 41, which is 39. Or I could put it here. 8 times 4 is 32, plus 7 is also 39. So it doesn't matter which one you plug it into, that's what we're looking for. But the key is that I want to know this side. We'll call it y. That's what we're looking for. This is a radius, so this is also 17. So you can use either triangle. But now we need to do Pythagorean theorem to find out what this side is. So 39 squared plus 17 squared equals y squared. This is 1810. Take the square root. We get 42.5 for y. So I think what we did, we set them equal first, and we found out what this is. This is why I need you guys to show your work, because sometimes if you come up with x and you did mess up farther, that way I can give you a hint as to what you need to do after that. So then we took 8 and we put it back in place. We found the side to be 39. Then we did Pythagorean theorem, took the square root, and found 42.5. Okay, finding perimeter means you're adding all sides together. So think about what we know. If these two, they appear to be tangent, so they are, so this one has to be 16. This one is 11, so it means this one also has to be 11. And this one is 9.5, so this one's also 9.5. So because all those lines had to be tangent, then we can find the perimeter by adding all of these together, and we get 73. So you had to go back to that rule that said if they connect to the same point out here, external point means outside the circle, these two lines are the same distance. So these were the same distance, these were the same, and these were the same. Okay, it works kind of the same for this one, but we got to do a little bit more figuring here. If we know this is 23, we know this part is 23. If we say 37.5, come out here to the edge, 37.5 minus 23 gives us 14.5. So it means this one is 14.5, which tells us this part's 14.5. If this one's 27.1, then this one's 27.1. 52.5 minus 27.1 gives us 25.4. Different color here. So that is this section, 25.4 and 25.4. So the reason we had to do all that was because we didn't know about this side right here, and so I had to know each section. So now we can add up. We already knew this was 52 and this is 37. But now we can add these two and these two and add all that up, and we should get 180. So that goes back to finding that tangent line out from the outside. Okay, I will post these notes and your assignment starting Monday for this coming week, and then I will put the due dates and any quizzes that we have along with it. So email me with any questions. Thank you.